Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi ta'ala wabarakatuh. Okay, so we will continue to chapter 2, which we call it as sampling distribution. Okay, before we go further into this topic, let's recap back. Okay, in terms of the definition of population and sample. Okay, a population is the collection of all possible observation of a specified characteristic of interest, whereas a sample is a selected subset of a population that is being investigated. It is a sub-collection of elements drawn from the population. Okay, so we already cover actually at the introduction part, but again I just recap back lah. Okay, so a population is our whole subject of interest, okay, that we want to study lah. Okay, so for example, again I'm use the the example of the student, all student in UiTM per list, either diploma, degree or PJJ student. Okay, whereas a sample is just a subset, okay, apart from the population. Let's say I'm just interested to focus on diploma student in UiTM per list. Okay, so why we need to do sampling, okay, or why we need to sample the population. Okay, first, it is physically impossible to check all items in the population. Okay, impossible to check all items in the population because it involves in terms of cost, time, right? Okay, that's why from getting the whole population, we just need to select a sample, okay, because we have the constraint in terms of cost, okay, and time basically lah. Okay, so that is the point number 2. The cost of studying all the items in population may be very high. Okay, cost. Okay, the sample results are usually adequate. Okay, that is mean by we can make a generalization or conclusion based on the sample that we have. Okay, we make conclusion on population based on the sample that we select. Okay, contacting the whole population will often be time consuming. Kita dah sentuhkan in terms of cost and time. Okay, and then certain tests are destructive in nature. Okay, for example, study of light bulb life. Sebab susah, kadang-kadang susah kita nak handle our population. So that's why tak perlu nak check all every items. For example, the light bulb tu lah. Okay, we just select a sample and then we said that okay, all the bulb are okay. Okay, number 2, what is parameter and statistic in terms of symbol and measurement? Okay, so recap back. Parameter is any measurement that we take from the population, and then statistic is the measurement that we take from the sample. Okay, so you need to ensure all this symbol, because you're gonna use all this symbol throughout this course lah. Okay, yang pertama in terms of size. Okay, so kalau we measure from the population, okay, so the notation that we're going to use is capital N, whereas if we measure or we collect from the sample, okay, the notation we use small n. Okay, and then mean. Okay, if we measure from the population, we use notation or symbol mu. Okay, this we call it as mu. Okay, and then if we calculate from the sample, we use symbol x bar. Okay, so this is how we pronounce this symbol x bar. Okay, and then second is variance. Okay, so sigma square. Okay, sigma square is notation for the parameter of the population. If we use s square, that is referring to the sample. Okay, and then standard deviation is sigma, and for the For the sample, we gonna use S. Okay, so beza variance dengan standard deviation. Variance dia ada kuasa 2. Standard deviation dia adalah punca kuasa variance kan. Okay, so and then the third one is proportion. Okay, so if we measure from the population, we're gonna use P. If we measure from the sample, we're gonna use P hat. Okay, so look at the formula. Okay, so the formula for the mean of the population, which is mu, is equivalent to summation of xi divided by capital N. Why we use capital N? Because if you want to calculate the population mean, that's why we gonna use capital N. But if we want to calculate the sample mean, we use the small n. Okay, so that is the difference between population mean and sample mean. Okay, this is average value. Mean is equivalent to average. Okay, we total divide by the summation divided by the total data. Okay, and then the population variance sigma square. Okay, since it was population, that's why kita guna capital N. Okay, so 1 over capital N times summation of x I minus summation of x square over capital N. Okay, because this is population, right? That's why dia dibahagi dengan capital N. Okay, so 1 bahagi dengan total number of data darab dengan summation of xi. This is mean by kita kuasa 2 kan setiap satu data tu. Okay, and then tolak dengan summation x. Maksudnya total kan semua x. Lepas tu baru kuasa 2. Kalau tadi kuasa 2 satu-satu bahagi dengan jumlah data. Okay, and then population standard deviation is just square root of the value of population variance. Okay, sample variance. Okay, kalau tadi population variance, kita bahagi dengan 1 over capital N. But for sample variance, we divide by 1 over N minus 1 small n. Okay, darab dengan summation of xi. Kuasa 2 kan setiap satu data set kita. Tolak dengan summation of x. Total semua x tu kuasa 2 bahagi dengan n. And then sample standard deviation is just square root of the variance. Okay, so what is the statistical inference? Statistical inference is concerned with making general conclusion about the population based on statistical information obtained from a sample. Okay, so again, ingat why we use sampling technique or statistical inference ni, because we want to make a conclusion of our population based on the sample. Okay, the researcher collect data from a sample that use the statistics generated to reach conclusion about the population from which the sample was taken. Okay, look at the example. An analyst for a transport company want to estimate the proportion of all Malaysian adult who own credit card. Okay, so dia nak estimate proportion yang ada credit card. Okay, to estimate this percentage, the analyst decide to survey 2,000 Malaysian from across the country. Okay, so population Malaysia ada berapa juta? 30 something, right? Okay, so we just want to make a survey or select a 2,000 Malaysian that has the credit card. Okay, so the probability distribution of statistic is called a sampling distribution. Okay, so kita boleh tengok in term of mean, variance and proportion. So later on nanti awak akan nampak lah sampling distribution tu. Okay, for example, the probability distribution of sample mean x bar is called the sampling distribution of mean. Okay, one way to examine the distribution is to take a population with a particular distribution, randomly select sample of a given size, compute the sample statistic, and attempt to determine how the statistics are distributed. Okay, what is sampling distribution 2.4? Let's say we consider all possible sample of size n that can be drawn from the population, and for each sample we compute the statistic. Then we obtain the distribution of the statistic, which we call it as sampling distribution. Okay, so from there also we can compute value of mean, variance, and also the standard deviation. Okay. Now let's Fx is the probability distribution of some given population from which we draw a sample size n. Okay, the probability distribution of the sample statistic x bar is called the sampling distribution for the sample mean or sampling distribution of mean. Okay, nama lain bagi mean ataupun average, dia boleh juga kita panggil sebagai expected value. So kalau jumpa terms expected value, that is mean, dia nak value mean lah atau average lah. Okay, so the expected value of the sampling distribution of mean denoted by mu x bar is given by, okay, expected value EX equals to mu of the distribution of mean, so tu diguna x bar, equivalent to mu, which is mu is the population mean. Okay, so maksudnya kat sini, kalau kita ada population with sample size n, okay, so kalau kita cari dia punya average sample tu, dia punya value dia will be equivalent to the population mean. Okay, so kalau kita calculate population mean, okay, kita dapat satu value x. Okay, and then kita ambil sample, kita calculate dia punya mean, value mean tu akan menghampiri ataupun equivalent to the population mean. So that's why dia kata expected value of the sampling distribution will be equivalent to population mean. Okay, and then the variance of the sampling distribution of mean, okay, just be denoted by sigma square x bar. Okay, variance sebab tu dia ada kuasa 2 is given by population variance divided by n. Okay, so kalau kita nak tahu variance of the sampling of our mean, cara dia adalah dengan membahagikan our population variance with n, number of sample size. Okay, kalau tadi population mean will equivalent to the, population of our sampling distribution will be equivalent to the population mean. Okay, dia sama. Tapi untuk variance pula, dia sama dengan population variance tapi kena bahagi dengan our sample size. Okay, the third one is standard error. Okay, standard error of the mean of this, standard error of the mean is the standard deviation of this sampling distribution of mean. Maksudnya, okay, tadi yang this one kita dah ada value variance kan of sampling distribution of mean. Okay, standard error adalah dia punya standard deviation. Maksudnya kita square root kan sigma square over n. Okay, this one. Nama lain bagi standard deviation is standard error. Okay, untuk sampling distribution. So cara dia adalah we square root sigma square over n. Okay, when we square root sigma square over n, we get sigma over square root n. Okay, suppose the population from which the sample are taken is normally distributed with mean mu and variance sigma square. Then the sample mean is normally distributed with mean mu and variance sigma square over n. Okay, the standardized variable associated with x bar is given by z equals to x bar minus mu over sigma over square root n. Okay, finally apa yang penting kat sini adalah this one. Okay, the sampling distribution of the sample mean can be written as, okay, this one. Okay, dia punya distribution of sample mean is normally distributed with mean mu and variance equal to sigma square over n. Okay. Kalau asalnya, okay, population dia follow normal distribution with mean equals to mu and variance sigma square. Okay, itu untuk population lah. Okay, dia punya mean kita kata equals to mu, variance dia sigma square. Okay, tapi untuk sampling distribution, okay, bila kita ambil sampel daripada population tu, and then which is sample mean lah kita dapatkan, ini kita cari dia punya distribution, this one dia jadi macam ni, dia follow normal distribution juga dengan mean equals to mu, dia sama macam population mean, tapi dia punya variance kita kena bahagi dengan n. Okay. Okay, now we want to look into the illustration. What does it mean by probability distribution and sampling distribution? Okay, look into the table below. Okay, a teacher asks the number of hours study per week to a population of 5 students. Okay, so this table show the number of hours study for each student. So kita ada Habib 7 hours, Hakim 7 hours, Fahima 8 hours, Fakih 8 hours, and Aisyah 9 hours. Okay, so since this example state that the population is equivalent to 5, okay, so we calculate the population mean. You just add up 7 plus 7 plus 8 plus 8 plus 9 divided by 5. We get mean equals to 7.8. And then population standard deviation, tadi formula kita 1 over capital N bagi dengan summation of xi square minus summation of xi kuasa 2 over n. Okay, so we get 0.7483. Okay, now we want to take a sample, samples of size 2. Okay, daripada population 5 ni kita nak ambil sampel yang mana size-nya 2. So the possible combination, okay, possible combination untuk 5 student ni kan. So kita akan dapat first combination Habib and Hakim lah yang bersize 2. Okay, so that's why yang saya listkan ni. Okay, 7, 7, 7, 8, 7, 8, 7, 9. Okay, saya listkan lah semua. And then this one pula 7 dengan 8, 7 dengan 8, 7 dengan 9. Okay, and then 8 dengan 8, 8 dengan 9. Okay, last kali 8 and 9. So kita akan ada 10 lah. 4, 7, 10. Okay, so bila kita dah ada possible combination tu, kita cari punya mean. Okay, 7 dengan 7 tadi, 7 tambah 7 bahagi 2 dapat 7 lah, dan seterusnya. Okay, now okay, so look at the value of mean. So we have 7, 7.5, 8, 8.5. Okay, so we convert all this value into the probability distribution table. Okay, so we can see that value of mean is between 7, 7.5, 8, and 8.5. Okay, so look at the probability of all this value. So look at the 7. So we just have one value of 7. So this means that the probability is 1 over 10. So because we have 10 set here, right? Okay, 7.5 we have 1, 2, 3, 4. So 4 over 10. 8 we have 1, 2, 3. 3 over 10. Okay, 8.5 we have 2. So 2 over 10. So if you total out all the probability, we will get 10 over 10, which is 1 lah. Okay, now we want to calculate the value of mean. So to calculate the value of mean is given by the formula of summation of x bar times probability of x bar. So we will calculate like this lah. 7 times 1 over 10 plus 7.5 times 4 over 10 plus 8 times 3 over 10 and 8.5 times 2 over 10. So we will get 7.8. Okay, so look at the value of the mean of sampling distribution. We get 7.8. And the value of population mean we get 7.8. So sama kan, maksudnya the mean of the sampling distribution will be equivalent to the population mean. Okay, now we want to calculate the value of variance. So the formula of variance is given by summation of x minus mean kuasa 2. Okay, where summation of expected value of x square equivalent to summation of x square times probability of summation of x bar square times probability of x bar. Okay, yang ni awak kena buat macam ni. Value x tu kita kena kuasa 2 kan, baru darab dengan probability of x bar. So 7 kuasa 2 darab dengan 1/10 tambah 7.5 kuasa 2 darab dengan 4/10 tambah 8 kuasa 2 darab dengan 3/10 tambah 8.5 kuasa 2 darab dengan 2/10. But kita kena tolak dengan value mean. Ni ada kuasa 2 so tertinggal. Tolak dengan 7.8 kuasa 2. So we will get 0.21.